Now I will solve assignment 7. Assignment 7. So, first question, consider a one dimensional chain of atoms of mass m. So, this is question number 1. The masses, they were like here, and this there, and this one were blue. So, this we took as mu s, this suppose we took as V s. This is displacement of each side due to, and C1 is the red line and C2 is for the blue. It is given also in the question. So, what will be the equation of motion? So, equation of motion will be given for the mu s will be mu s dot C2 Vs minus mu s minus C1 into mu s minus V s minus 1. So, we can know that this is for the diatomic chain, as Professor Holbrook has done in the lectures. We saw that it was just like that, because for both them C2 and C1 were same. So, we took that both as C, but here they are different. Simple as that. Simply add for Vs, we will have C1, just the nearest neighbor atom interaction. C1 will be Us plus 1 minus Vs minus C2 into Vs minus mu s. So, these are the two equations of motion. This is option C. Moving to the next problem 2. For question 1, if C1 is less than C2, frequency of the acoustic and optical modes of the frequency of acoustic and optical, what will be their value at Ka equals to pi? So, first will answer. So, now we have equations m u s dot minus equals to C2 Vs minus mu s minus C1 Us minus Vs minus 1, this is 1, and we had m Vs double dot equals to C1 Us plus 1 minus Vs minus C2 into Vs minus Us, this is U is 2. Now, we put the solutions are the just plane travelling wave. So, we put plane wave equations. Plane wave solution for Us, I can take the amplitude to be A1. They are at different amplitude, but the waveform is same for both of them. This is A2 into e to the power I Ksa minus omega t. These are the two equations. Now, if the two equations we put these two values of Us and V in 1 and 2. Okay. So, by putting from 1 we will get from 1 A1m minus I omega whole square e to the power I Ksa minus omega t equals to C2 A2 minus A1 e to the power I Ksa minus omega t minus C1 A1 e to the power I Ksa minus omega t minus A2 e to the power I k. This will be s minus 1 a, because it was s minus 1 a side minus omega t. So, here we just make it much simpler. C2 A2 minus A1, we just cut this part from both sides. Here only this Ksa term will go out and minus K term will remain. So, this will be C1 A1 minus A2 e to the power minus I k. This k due to that s minus 1 for that part, it is written here. So, we take this as 3. Similarly, by from 2 we will get, and I am just writing the simplified form, A2 m omega square C1 A1 e to the power I k minus A2 minus C2 into A2 minus A1. We take this at equation number 4. Okay. So now rearranging question 3 from 3, I am just taking everything in one side. So for A1 into m omega square minus C2 minus C1 plus A2 into C2 plus C1 e to the power minus I k a equals to 0, we take this as 5, and from 4 we can get, this is 3, and from 3 we will get this, from 3 rearranging, and from 4 we will have A1 into C1 e to the power I k a plus C2 plus A2 m omega square minus C1 minus C2 equals to 0. This is our question 6. So, we have 5 and 6, this 5 and 6 we have this A1 and A2, this A1 A2 A1 A2. So, we have these two equations with two variables. Suppose we take this A1 and A2. So, the coefficient matrix of both these two equations will have to be 0, the determinant of the coefficient matrix. We are just doing that by doing m omega square minus C2 minus C1 and C2 plus C1 e to the power minus I k a, and this will be C1 e to the power I k a plus C2 m omega square minus C1 minus C2, that it will be 0. This is just the coefficient matrix I took, and just I am taking the determinant to 0. This is just the eigenvalue equations. So, now the value we will get by this, if we do that, m omega square minus, we are just taking the determinant, C1 minus C2 whole square will be C2 square C1 square plus C1 C2 e to the power I k a plus e to the power minus I k. Just work it out step by step, you will get this. So, this we know will be 2 cos k. So, m omega square minus C1 minus C2 their whole square, we will have C1 square C2 square 2 C1 C2 cos k. Now, at k equals to pi we are given. So, cos pi will be our minus 1. So, m omega square minus C1 minus C2 whole square, we will have C1 square plus C2 square minus 2 C1 C2. So, this is my question, and here it is, we have given that C2 is greater than C1. So, from the previous equation, from this equation I can write it as m omega square minus C1 minus C2 whole square equals to C2 minus C1 whole square. Because is C2 greater than C1, I am writing like this, since C2 greater than C1. So, now if we just take the root, m omega square minus C1 minus C2, it will be plus minus C2 minus C1. The optical mode we know will be optical mode, it will be the higher part. So, plus. So, m omega square minus C1 minus C2, it will be plus C2 minus C1. So, we see C1 C1 goes on. So, omega is your 2 C2 by m. This is for optical. And for the acoustic mode, when take the minus of this. So, m omega square, to take the minus of this. So, m omega square minus C1 minus C2 will be minus of C2 minus C1, or plus C1 minus C2 m omega square C1 C2. So, here C2 will go on, and we get omega will be 2 C1 by m. This is for acoustic mode. So, at k equals to pi, these will be the values. So, your correct option is B. Question number 3. Question number 3 is for question 1, what will be the displacement ratio Vs by mu s at Brillouin zone boundary for optical and acoustic mode. Okay. So, we took that Vs equals to A2 e to the power I KSA minus omega t, and Us I got A1 e to the power I KSA minus omega t. So, actually the ratio of Vs by Us will be just the ratio of their amplitudes, this part will go on. So, the eigenvalue equation, now for the previous problem we saw that these two equations, this 5 and this 6, this 5 and 6, if we can write this in a matrix form, we will get m omega square minus C2 minus C1, C2 plus C1 e to the power minus I k a, and C1 e to the power I k a plus C2, and here m omega square minus C1 minus C2 into A1 by A2 will be 0. This is just the equation we got, and we now put k equals to pi here. Already we are putting k equals to pi because we have asked the question at below and zone boundary. At below and zone boundary it is k equals to pi. If we put the value of k equals to pi here, so we get m omega square minus C2 minus C1, C2 minus C1 because e to the power minus I k a e to the power minus I pi will be still minus 1. So, C2 minus C1, and here it will be minus C1 plus C2 into m omega square minus C1 minus C2 into A1 by A2 equals to 0. So, now for acoustic problem, from the previous question we got omega square equals to 2 C1 by m from the previous problem acoustic mode 2 C1 by m. So, we will just put the value here in the equation. In this equation put the omega square value here. So, we will get m 2 C1 by m minus C2 minus C1, and this will be C2 minus C1, this is minus C1 plus C2, this is m 2 C1 by m minus C1 minus C2, A1 A2 is 0. So, goes and this 2 C1 minus C2 minus C1. So, it will be C1 minus C2, this is C2 minus C1, this is minus C1, I can write it as C1 minus C1, C2 minus C1, and this is 2 C1. So, I can write it as C1 minus C2, A1 A2 equals to 0. So, now if we just take one value, one equation, so C1 C2 into A1 plus C2 minus C1 into A2 equals to 0. So, C1 minus C2 into A1 equals to, this part will go, they change sign. So, C1 minus C2 into A2, this both goes. So, A1 equals to A2. So, the ratio A2 minus A1 will be plus 1. This is for the acoustic mode. Similarly, for the optical, simply again just that equation m omega square minus C2 minus C1, C2 minus C1, we have already put k equals to pi C1 plus C2, and this will be m omega square minus C1 minus C2 into an A2 equals to 0. Now, we put omega square equals to 2 C2 by m. From the previous problem here we see that for the optical it was omega square 2 C2 by m. So, again I put that values, put omega square 2 C2 by m, and I will get C2 minus C1, just put the value of omega square here, and C2 minus C1, C2 minus C1 minus C1 plus C2 minus C1 plus C2 into A1 A2 equals to 0. So, C2 minus C1 into A1 plus C2 minus C1 into A2 equals to 0. So, we get here A2 by A1 will be minus 1 for optical part, for optical mode. So, the correct option is this A1 by A2 by A1 will be minus 1 for optical, and A1 A2 by A1 will be plus 1 for acoustic. This means that here you can see that A2 by A1 is plus 1. So, that means that both mu s and Vs will move with same amplitude and in the same direction. They both will move in the same direction, and here the A2 by A1 is minus 1. So, that means they both will move, Us and Vs, they will move at the opposite direction, but with equal amplitude. Moving to the next problem, the question number 4 we have, in terms of Debye temperature 3D, the internal energy of the lattice, in the Debye model, what is this? The internal energy of the lattice. Internal energy of the lattice. So we know that from the derivation we have already got u equals to 3v by 2 pi square mu s whole cube into k to the power 4 by h cut whole cube into t to the power 4 into 0 to x d dx e to the x cube e to the power x minus 1. This was also derived in the lectures by Professor Halbara sir, and there x is written as h cut omega by kt. This was the form of the internal energy. This is also done in the book of Charles Kittel, you can chapter 5, you can see also here, and here x is h cut omega t, I can write x t as theta d by t, where theta d is my Debye temperature. Okay. So now this is for a 3D. Suppose this is your kx, ky and kz. This kx, ky, kz will have kx, if we use periodic boundary condition, this kx, ky, kz will have value 2 pi l plus minus 2 pi l into nx, and this is nx for kx, and ky will be value of plus minus 2 pi by l into ny. We can get this from the periodic boundary equation, it is just trivial, nz. So the smallest, the occupied by this kx, ky and kz, this kx and ky and kz will be 2 pi by l whole cube. So 2 pi whole cube by l means l cube, this l is the length, and this is the total volume of the cube, this is the smallest cube, and this is the smallest area of in the k space one state can occur. So this is by v. So here our total number of modes will be n will be, this is your smallest part, and if we consider a sphere with value k, so with the radius k, this along the sphere, this in 3D, this how many of this small cube are there. So there will be the number of states obviously. So this will be given by total area. Now the volume is 4/3 pi k cube, this is this volume of the sphere, and for one smallest rectangle is given by, as we got from the previous formula, is 2 pi cube by v. So 2 pi cube by v, we get this. So n will be your v by 2 pi cube into 4/3 pi k cube. So v by 8 pi cube into 4/3 pi k cube, so 442 pi square. So you have v by 6 pi square k cube. Okay. So your k cube is 6 pi square n by v. Okay. Now we know that omega is Vs by k, it is for the acoustic mode, the acoustic approximation we can take this Vs into k, it is the Debye approximation. So Vs is your velocity of sound, this is the dispersion relation. So this is omega equals to Vs into k, so you can write k equals to omega by Vs. So this k cube we can put omega cube by Vs cube, just putting this value in this equation, 6 pi square n by v. So we get omega cube equals to 6 pi square n by v into mu cube. So there will be obviously there will be a highest frequency about which it can get, the number of states there can occur. we denote that highest frequency as omega d, the highest frequency, or we can say the cutoff frequency above which there will be no states available. Highest frequency is the Debye frequency, we write this as omega d. This is, if this is the n number of states, we can write omega as the omega d, can write omega d. So, omega d cube is your 6 pi square mu s cube, I am sorry, mu s cube into n by v. So, and theta d, your d by temperature is h cut omega d by kb. So, this will be h cut mu by kb 6 pi square, from here we get the omega d value, and just put the value omega d here, 6 pi square n by v in 1/3, and sigma d cube will have h cut cube mu cube by k cube 6 pi square n by v. Suppose this we take as equation, this is one equation, and u we already got 3v kb4. This 3 is coming actually as there are 3 kinds of polarization, 2 transverse, 1 longitudinal, and 3v kb cube into t to the power 4 by 2 pi square mu cube, this is Vs, and this is h cut cube 0 to x d dx x cube by e to the power x minus 1. This we got already. So, now this we can replace this value here by putting, we get u equals to, I am trying to write this as, this is kb t4, just watch it closely, I am doing it, 2 pi square Vs cube h cut cube into h cut cube mu cube by theta d cube into 6 pi square n by v. See that I can write this, I can simply write this e to the power x minus 1, just the cube value I am just replacing it here. Suppose I am taking this k cube here, k cube from here, and replacing this k cube by this form. Here suppose here then I can write this k cube equals to your theta d cube, and here I am taking one k and one another, the k cube part, this is k to the power 4 here. So, there will be k cube, I am replacing this k cube, and again by eliminating everything you see that there will be lot of elimination here, this mu s there will always be, and by that we will get mu equals to this 2 3 will be, this pi square will be, and it will be 9 n kb, this will be n into kb into t by theta d whole cube 0 to x d dx x cube by e to the power x minus 1. So, this is R. So, it is option B. So, this is gone for problem 4. So, now question number 5 we have KCl, its Debye temperature is given as 230 Kelvin, specific heat at 5 Kelvin is given as 3.8 into 10 to the power minus 2 joule mole inverse Kelvin inverse. So, what will be at Cv at 2K? So, the Cv is written as 234 T by theta d whole cube into n kb. These are the constants of pi square n and v and everything. So, we just put the every values and we will get this constant number 230. So, the main part is actually is your Cv proportional to T by theta d cube. So, here is the KCl is same. So, theta d will be same. So, simply Cv by 5k by Cv by 2k, this will be proportional to 5 by 2. Okay. This is your given as 3.8 into 10 to the power minus 2. So, Cv at 2k will be given as 2 by 5 whole cube into 3.8 into 10 to the power minus 2. So, this will be 2.4 into 10 to the power minus 3 joule mole inverse Kelvin inverse. This is option A. Now, similarly for question 6, NaCl has same crystal structure as KCl. So, in both case n will be same, and Debye temperature of NaCl Debye temperature of NaCl is given as 310 Kelvin. So, what will be the specific heat of NaCl? Specific heat of NaCl at 5 Kelvin. So, simply Cv 5K of KCl by Cv 5K of NaCl, we get 234 T by theta d KCl whole cube NKB by 234 T by theta d NaCl whole cube NKB. N for both of them are same, so this will go on, this will go on. T will be same because here for 5 Kelvin, both are 5 Kelvin, so T will be same, so they will also cut off. So theta d NaCl by theta d KCl both cube, and here this is given from the previous problem we had. This is 3.8 into 10 to the power minus 2, this is Cv 5K NaCl. So simply just putting the value, this theta d NaCl is given as 310 Kelvin and theta d KCl is also given for the previous problem as 230 Kelvin. So by calculating, just put the value in the calculator and we will get 1.55 into 10 to the power minus 2 joule mole inverse Kelvin inverse. This is D. Moving to the next question, question number 7. We have for the germanium, it is given 80, the thermal conductivity is given by this, Debye temperature is 360 Kelvin, your atomic weight is given as 72.6 and density is 5500 kg meter cube. So we know that 1/3 CVL. So CVL, this is the specific heat per unit volume, this will be the velocity of sound here, and L is will be the mean free path, what we have to calculate. So L is 3K by C into C is, this is the specific heat per unit volume, I can write this like this, into V, the velocity of sound. Now we know Cv is given as V kb to the power 4 theta d cube 2 pi square mu s whole cube h cut cube something, and the theta d cube, there are relations h cube bs cube into 6 pi square n by v by k cube. So these are the relations we got, and there is a lengthy calculation, and you can get also the, we know that rho is mass per volume. So we got mass, atomic weight with, and with the density we can calculate the V, and if we put every values here, suppose from here we can calculate mu s, theta d is everything is given, and here we will calculate the Cv by putting the value of Vs, and by putting we will just see that L will be 30 nanometer. Just put the values and we will see. Moving on to the next question, question number 8. Debye temperature of diamond, theta d for diamond is 2000 Kelvin. At 4K and 5K, 50K, what the conductivity is given as K4 and K50. So you see here that this 4K and 550K, they are very less than this Debye temperature. So we see that there will be no Umklamm process, and all the scattering will be determined by the defects and the sample boundary. So there will be no T dependence of the thermal conductivity of the material. So it will just be normal process, and Cv will have is proportional to simply Tq. So we have kappa, I mean this K, thermal conductivity, this will be just proportional, this is we know that this is 1/3 CVL. So K will be proportional to CV, I mean the specific heat. So K4 by K50, the ratio will be 4 by 50 whole cube. This is because K is proportional to T cube. We have this phonon region is K T cube region, because at the higher temperature it would be just be constant of Dulong-Petit's law. CV will be 3R. So this will get almost 5 into 10 to the power minus 4. So the correct option is option A. Into question 9. By using Debye approximation in a, now we have in a 1D monoatomic crystal lattice, monoatomic lattice I have, and the lattice constant is given by A, interatomic spacing is A, speed of the sound is Vs, and Debye temperature is theta T. Okay. So now here for the 3D we got that this is Kx, Ky, Kz, everyone was 2 pi by L, just using the periodic boundary condition we are getting, these values are allowed. Here 1D this will be only one K value and K is 2 pi by L. So density of states, we can write density of states for 1D, I can write as d omega L by pi, I can write d omega by dk. If we use the periodic boundary condition, we will get this 2 pi, and if we this long chain we will have pi by L. Just seek detail if you have any confusion. So this pi by L d omega by dk. So the Debye approximation we have omega equals to Vs k. So d omega dk we will have Vs. So again up to the Debye frequency omega d omega, this will be L by pi 1 by Vs. I am just putting the value of d omega here, 0 to omega d omega. So it means L by pi omega d by Vs, this is 2. Then write it as equation 2, and again we know that this is equals to n, the total number of modes here. So for 1D we know L is total length is n into a, total number of modes into interatomic spacing or total number of atoms in a monoatomic lattice. So here L by pi into omega d by Vs equals to n, we can write n as L by a. Okay. So L goes out, so omega d is your pi Vs by a. This is suppose 4. Now we know h cut omega d is your k theta d. So this is just the Debye temperature and the Debye frequency. So h by 2 pi, I am putting the value of omega d, pi Vs by a, k into theta d, this pi goes out. So your theta d is given as h Vs by 2 k a. So this is the Debye temperature for the 1D monoatomic lattice. This is option B. And the last question, question 10, for the same previous problem, that is for 1D, calculate CV. So total energy will have, total energy U is up to this omega d, this is d omega, density of states, this is number of states per along that d omega, and h cut omega, this is the Debye model. So we get d omega, this d omega I can write this as for the previous like L by pi 1 by Vs, this is just 1 by, this is famous Planck equation. So h cut omega by kt minus 1 h cut omega. So U will be L by pi 1 by Vs 0 to omega d h cut omega by e to the power h cut omega kt minus 1 to t omega. So this is your form, and now we put x equals to h cut omega d by kt, and just we just put this here, we will get u will be L by pi 1 by Vs k square t square by h cut 0 to omega d h cut omega by kt by e to the power h cut omega kt minus 1 into h cut by kt into d omega. We just put the h cut by d omega, h cut kt h cut, I am just introducing them, and I got h x equals to h cut omega d by kt and omega d equals to theta d by t. So, you will get L by pi this omega d. Now, if we write them as x k square t square by h cut square, this is k square is 0 to x, suppose this will be x by x by e to the power x minus 1 dx, this just x equals to omega d kt just here. If we replace x omega d by x, and then this omega d will be x, and x I can write also as this is theta d by t, because x equals to your theta d by t, here I can get. So, for t tends to 0, x will tends to infinity. So, we will have u equals to L by pi 1 by Vs k square t square by h cut into 0 to infinity x e to the power x minus 1 dx, and this value we know this is pi square by 6. So, if we put the value here, this value is pi square by 6. So, if we put the pi square by 6, we get u equals to pi square by 3 L k square by h mu s into t square, and again we got theta d is h mu s by 2 k a. So, u will be given as pi square by 3 into L k square into 2 k a by h mu s, I am just forming it like that, into by 2 k a into t square. By substituting everything, we will get pi square by 3 L k 2 a t square 1 by theta t, this is t square. So, C v will tell you del t, this will be just pi square by 3, the t square 2 will come, this 2 will cancel out, this 2 and this 2 will cancel out. So, it will be 1 by theta d L k by 2 a into 2 t, and this 2 has already cancelled out. So, C v is your pi square k t by 3 a theta d. This is your problem, and you can take L equals to 1 because a is very small and n is a large number. So, we can always consider this L equals to 1. If we consider that, it is pi square k t by 3 a theta d. This is your option C. Thank you.